Welcome to The Explainer. Today, we are digging into something absolutely fundamental, the nuts and bolts of what makes a huge construction project actually work or fail spectacularly. We're going to be talking about the specific contract clause that's all about quality, from, the tiniest brick all the way up to the massive turbines.
So, what exactly ensures a bridge can stand for 100 years, or a skyscraper can reach for the clouds without any issues? Well, it all boils down to the quality of three core things, right? The machinery that makes it run, the materials it's built from, and of course, the skill used to put it all together. And guess what? All three are governed by one super crucial clause in the construction contract.
So here's what we're going to cover. We'll look at the project's three pillars, how you execute with quality, how you test it all, what happens when things go wrong, and finally, your practical engineering playbook. Yep, we are opening up the playbook, specifically Clause 7 of the FIDIC 2017 Red Book, to see exactly how quality is defined, enforced, and ultimately delivered on a real-world construction site. Okay, let's get right into it. Section 1, the project's three pillars. We got to start at the foundation, right? Before we can even talk about quality, we need to understand the three pillars that every single construction project is built on.
Okay, first up is plant. And no, we're not talking about greenery here. In the world of FIDIC, plant is all about the big, heavy-duty hardware. Think turbines, generators, those massive HVAC systems, basically the stuff that's usually made somewhere else and then brought to the site to be installed as a permanent, working part of the final building.
All right, next up, we've got materials. This is pretty much the catch-all for everything else that becomes a permanent part of the structure. We're talking about the essentials, the concrete, the steel rebar, all the pipes and wiring. Basically, if it's a physical thing going into the project and it's not plant, well, it's a material.
But, having the best plant and the best materials in the world is totally useless without our third pillar, workmanship. This is the one you can't really touch. It's all about the standard of execution. It's the difference between a master craftsman laying a brick perfectly level and, well, someone just slapping it down. It is the skill and care that actually turns a pile of expensive parts into a solid, lasting structure.
So that's our three pillars. Simple enough. But how does the contract actually make sure that quality is baked in right from the very beginning? Well, that brings us to Section 2, executing with quality.
Okay, Subclause 7.1. This really sets the baseline for everything. I like to think of it as a kind of quality pyramid. Down at the bottom, the absolute base, you have to use the right tools and non-hazardous materials safely. Then, moving up, the work has to meet the specific requirements spelled out in the contract. And right at the top, the peak, it has to align with recognized good practice, which is kind of like the unwritten professional standards of the entire industry.
Now here's a really critical checkpoint before anything gets permanently installed: submitting samples. This is a huge quality gate. It gives the engineer a chance to physically see and approve, say, the bricks, the tiles, or the exact paint the contractor wants to use. And this has to happen before they go and buy tons of it and stick it on the building. It's a simple step that prevents massive headaches down the line. And this is where you can really see the back and forth, almost like a dance, of the inspection process. See how it works? The contractor has to get the work ready and then officially tell the engineer, hey, we're ready for you. The engineer then has to respond without dragging their feet. They either come inspect it or they give formal notice saying, you know what, we don't need to see this one. It's all about that clear, documented communication. All right, so we've set the standards for how the work should be done. The next logical step, and it's a big one, is verification through testing. Let's get into Section 3, putting it to the test. This isn't just about looking to see if it seems right, it's about actually proving it performs the way it's supposed to. So the contract is super clear about the testing procedure. It's not a casual thing. Step 1, the contractor has to provide everything needed for the tests: the people, the gear, the materials, the whole shebang. Step 2, they have to let the engineer know when and where the test is happening. The engineer can then show up to witness it. And finally, if it all passes, the engineer signs off on the contractor's test certificate. And that signature, that's not just a formality. It's the official proof that a quality standard has been met. But what if it fails? What if the plant or the materials or the workmanship just doesn't pass the test? Now this is where the contract really shows its teeth. A failure isn't just a minor hiccup. It kicks off a whole formal process for dealing with it, making sure that bad work doesn't just get ignored or hidden. And here are the consequences, laid out plain and simple. The engineer issues a formal notice saying, hey, this is defective. The contractor then has to come back with a plan to fix it. The engineer can say yes or no to that plan. But here's the kicker. The retesting, that is all at the contractor's risk and, more importantly, at their cost. Now that is a massive financial incentive to get things right the first time around, isn't it? Okay, so we know what happens when things fail. Now in Section 4, we're going to look at fixing those failures, and then talk about ownership. We'll get into exactly how these defects are formally remedied, and then we'll tackle that really critical question. When do the plant and materials actually stop belonging to the contractor and become the property of the employer?
And this is a really important point. The engineer's power doesn't just disappear after one test or one inspection. No way. They can, at any time before the project is handed over, instruct the contractor to rip out and replace anything that doesn't meet the contract specs. Think about that. It's the ultimate safety net, the final backstop to guarantee quality.
Now, this timeline, this is absolutely critical. Why? Because it tells you the exact moment that ownership of all that plant and material transfers from the contractor to the employer. And trust me, this is not just some boring legal detail. This has massive implications for insurance, for risk, for who pays if something gets damaged or stolen. And the most important thing to remember here is that ownership transfers at whichever of these times happens first. Okay, so we've gone through a lot of the what and why. Let's wrap this up with Section 5, your engineering playbook. We're going to boil all of this down into a practical guide for any engineer who's actually out there on site, responsible for making sure all this happens. Look, as an engineer on site, you are way more than just a supervisor. You are the guardian of the specification. You're the one who takes all these words in a contract and turns them into a physical reality. You make sure that the promises on paper are actually honored in steel and concrete. So here it is, your checklist, your key takeaways. First, verify. Check every single sample against the spec before you give consent. Second, document. Write down every inspection, every test result, every notice, meticulously. Remember the old saying, if it's not in writing, it didn't happen. Third, communicate. When something's not right, you have to communicate it clearly and formally, just like the contract says. Fourth, understand that ownership transfer moment. And finally, act. Be decisive when you have to order remedial work to protect the project's quality and safety. Get these 5 things down and you'll have Clause 7 under control. So, let me leave you with this final thought. How can you use these clauses for more than just policing quality? Instead of just catching mistakes, how can you leverage this whole structure, the samples, the inspections, the testing, to build a site culture that actually prioritizes quality right from the start? Think about it. This isn't just a rulebook. It's a tool to build a foundation of excellence in every single project you manage.